Hi guys, so this is going to be the third way of solving systems. Okay, sometimes graphing's easiest, sometimes substitution might be easiest. I prefer to use elimination whenever possible. Now, I would highly recommend if you had two nice y equals equations, so like 2x plus 1, and I don't know, I'm just making this up, 1 half x minus 3. I would definitely graph those or do substitution. I would graph just because of the fractions that can be annoying in substitution. But when you have two like this that are technically in standard form, I would not graph. I also wouldn't do substitution because notice that none of the coefficients are 1. Those aren't convenient methods to solve this substitution. So there's a method called elimination. And we're going to do exactly what it says. We're going to eliminate one of the variables. So we're going to combine two equations by adding or subtracting them. I generally add them. Some people subtract them. I find more people make mistakes more often than not. So by doing this, our goal is to eliminate one of the variables, leaving us with a simpler one variable equation. So if you look at this first one, treat it as if it's a big addition problem. Do you see how you have a positive 4y and a negative 4y, and they'll just cancel out? So add 7x and 3x, you get 10x. Those cancel, bring down an equal sign, add the 7 and 3 to get 10. Now we have the equation 10x equals 10. Well, we can solve for x and we get 1. Now remember, the solution to a system is an ordered pair. Okay? So to find the y, I can plug that x value back into either one of these equations. I'll just do the top one. It does not matter. You should get the same answer in either. So if I put 1 in for x, I have 7 plus 4y equals 7. Now, to solve for y, let's subtract 7 from both sides. So I have 4y equals 0. Let's divide by 4. 0 divided by any number is just 0. So the solution here is 1 comma 0. Okay? Let's try another one. That one worked out really nice because you had two values that canceled out or eliminated immediately. That's not always going to happen. So look here, nothing cancels out immediately. It's not like I have a positive 2x and a negative 2x. But we can easily get these y's to eliminate if only one of them were negative. Okay, so what we're going to do, I'm going to leave the top one alone. It doesn't matter. That's just the one I'm picking. And I'm going to take this whole bottom equation and multiply it by negative 1. So 2x plus 1y equals 100. I'm leaving the top one alone. Now, I have to multiply every piece by this negative 1. So now you can see, oh, if I treat these like a big addition problem now, 2x with a plus a negative 6x, it's negative 4x. 1y plus a negative 1y, those cancel. Bring down the equal sign. 100 plus negative 200 is negative 100. Now I have one equation with one unknown. So let's solve for x. So x is 25. Okay, now we got to find y. So I'm going to put it back in the top one. It really doesn't matter which one. So put 25 in for x. So this would be 50 plus y. Subtract 50, and y is 50. So 25 comma 50 is the solution there. Okay. Now notice here, nothing cancels as it is. But this is a positive 3y and this is a negative 1y. Wouldn't it be really, really nice if this were a negative 3y? So to get that to happen, let's multiply this entire bottom equation by 3. So leave the top one alone. Okay, this would be 15x minus 3y equals 39. Get a big addition problem. I get 17x. Those cancel. That's 51. Divide by 17, and x is 3. So let's put that in for x. Once again, I'm just doing the top one. You could put it back into either. That's 6 plus 3y equals 12. Subtract the 6 over, divide by 3. So here my answer is 3 comma 2. All right, one more. Now notice, nothing eliminates nicely here, and it's not like I can just multiply one of them. So every once in a while, you might have to multiply both of the equations by a value. So what I think is the easiest is I'm going to multiply the top one by this 5 here, and this bottom one by 3 here. Now, if I do that, these would become 15x and 15x. So one of them needs to be positive and one needs to be negative. It does not matter. Pick one. So I'll just make that one negative. So I'm going to rewrite both of these here. So the top one would become negative 15x minus 35y equals, negative 75. The bottom one, 15x plus 6y equals negative 12. Big addition problem. These cancel. In all the other ones, I canceled the y's. It doesn't matter. You can cancel the x's or the y's. So that's a 6. Okay, so let's add up what's left here. So negative 35 plus 6 would give me a negative 29y, and this would give me a negative 87. Okay, so if I divide by that negative 29, get 3. Whoop, 3. Okay, so now I got to find x. Now, you could plug y equals 3 back into this one, this one, this one, this one. I'm going to go back to probably this one or this one. I wouldn't, you can do these. I just am not going to because the numbers are bigger, so it's a little more annoying. So let's do the top one. So put 3 in for y. So now 3x plus 21 equals 15. Subtract 21 and divide by 3. So here my answer is negative 2, 3. Now, real quick, so we've done graphing, and what we noticed is when they, total rando example here, if I have a line that goes like this and a line that goes like this, the point where they intersect, that's the solution. Okay? And when I did graphing, I think I did one example where they were parallel lines with a different y-intercept. Those had no solution. Okay? And then there's also the rare case where so these are parallel, but with a different y-intercept. Okay? They could be the same exact line. Okay? So say you get out, say you have y equals 3x plus 2, and then I give you another one that's negative 3x plus y equals 2. Well, clearly, if you solve that, you're going to get the same thing. So you could have a system that looks like that, and they're the same exact line. So that means every single point would work in every single equation. So this would be infinite solutions. Okay? Any ordered pair that's on that line is going to work. So any x value you pick, whatever you get for y, you're going to get the same y in both of them. Okay? So those are just some of the no solution and infinite are special cases. I know if you had started the 4.2 graded assignment, there was a special case there. We haven't done a ton with those lately. Okay, not lately. We haven't done a ton with those at all due to time. I have to map out days to see how much time we have left. If we have time, I might do a video on some of those special cases. I just have to check our time. Okay. I will have office hours on Thursday if anyone has any questions or needs any help at all. I hope you guys are well.